All right, we are going to be talking about functional groups today, what they are, what they do a little bit, how to recognize them major. Okay, so these are functional groups. While we've been studying science, we've found that there are certain patterns of elements that repeat themselves over and over and over again. Okay, these patterns we gave a name to so that we can recognize them a little bit faster so that we can talk about them. And so we're going to learn about 6 of these patterns of elements. The first one we're going to talk about is an alcohol, okay, and that is COH, just like that, okay. What's before the C and what's attached to that C we don't care about. As long as we have this in that molecule somewhere, we have an alcohol. And remember, not all alcohols are the stuff that's going to make you drunk and stumble around. That's one type of alcohol. There are thousands and billions of types of alcohol. So make sure that you're not confusing those two. We're not talking about drinking alcohol. We're just talking about a pattern of atoms that we're seeing. All right. Another functional group that we have is an ether. Sorry about that S. I'm thinking ahead too far, so this is a T. Ether is we have a carbon bound to an oxygen bound to another carbon. Okay, and it is this pattern that we're looking for. Yeah, the C's are going to be bound to other things, and you know they want 4 bonds and everything like that. But as long as I have a carbon bound to an oxygen bound to a carbon, we have an ether. All right, the one that I just about wrote just a second ago. I did it again. An ester. Now I'm thinking back to the other one. An ester, okay, is when we have a carbon double bound to an oxygen, then to another oxygen, and then to a carbon. Okay, a carboxylic acid is very similar to an ester. We have carbon double bonded to an oxygen, bonded to another oxygen, just like with the ester, but instead of bonded to a carbon, on the other side it's bound to a hydrogen, which makes it the acid. Okay, a ketone, which is just a carbon which is bound to stuff and double bonded to an oxygen. And lastly, we have an amine, and these things are stinky. They smell horrible. That's carbon bound to a nitrogen. Okay, so those are our 6 functional groups. So let's look at some things and figure out what we've got. So if I've got this molecule looking at me, we look for the patterns, and we see that we have, well, the first thing you should always look for is where do I have oxygens. Okay, that'll tell you where you have your functional groups at. So we've got our oxygen right there. So we look and say, okay, I've got my oxygen. On the one side I've got a carbon, on the other side I've got a hydrogen, so this is an alcohol. Okay, there's my functional group in this molecule. All right, another one that we could look at. Remember, if they're dashes, then they are just hydrogens. Just to save myself a little bit of time here. So here is my oxygen. It has just a double bond to a carbon, so I would say that this is a ketone. Alright, so a lot more complicated all of a sudden here, but we can still do the exact same thing that we've done before. Let's go through and find all the oxygens in this molecule. We've got one there, we've got another one there, we've got one there, we've got one there, and we've got one there. We do have another guy that's sticking out here who isn't carbon or hydrogen. He is another functional group that we're not going to talk about, that we haven't talked about. So you don't have to worry about it, but you know he could be. So we've got in here, forgot my lone pairs on that guy, 5 different oxygens. So let's look through and try to identify these guys. This guy we see has a carbon on one side and a hydrogen on the other, so that is an alcohol. This guy we see is the same, so he is also an alcohol. This guy, we have an oxygen that is double bound to a carbon, so he is a ketone. This guy, we have an oxygen double bound to a carbon, so he looks kind of like a ketone. We have a carbon, oxygen, carbon, so he looks kind of like an ether. But if we look at the whole thing put together, we see that it's neither of these guys. Okay, that whole thing makes up a new pattern, the ester. Okay, so this whole thing here, let's actually put him in the same color, is the ester going on. How do you tell which one it is? The bigger one always wins. So if you have a ketone and an ether that are together, you just made an ester. Okay, the bigger one will always win in that battle. Okay, hopefully this helps. Always look for the oxygens and then match it to the pattern. You will have to have the patterns memorized. There's 6 of them to memorize, so make sure that you have that done. And we'll talk to you in a bit.